this is Mr. B. Giriraju, Professor of EC Department, ACE Engineering College, Hyderabad. So in the last video, I have given explanation for the ohm meter. Generally, here we are having two types of ohm meters: series type of ohm meter and shunt type of ohm meter. Now, I will explain applications of ohm meter. So before going to explain applications of ohm meter, once again I will recall the function of the ohm meter. So actually, what is the function of ohm meter? With the help of ohm meter, you can measure resistance in ohms. In the same way, you can check continuity of the circuits. So generally, here we are having two types of ohm meters. First one is the series type of ohm meter, and the second one is the shunt type of ohm meter. A series type of ohm meter having two multiplier resistances, one PMMC meter, one battery, across terminals connect unknown resistance. So with the help of unknown resistance, we can measure, so require resistances. So here required means this is unknown resistance. That means here with the help of unknown resistance, you have to calculate it. You have to calculate intermediate values of the resistance. So towards that, you have to consider calibration of the series type of ohm meter. So actually, in the circuit diagram, we have terminals AB. So initially, the terminals AB are shorted. So in that case, current through unknown resistance is maximum. So that means Rx equal to 0 because of we have shorted terminals AB. So in that case here Rx equal to 0, I is maximum. So now pointer marked on right side of the dial. So actually in this case, so we are having dial of series ohm meter, left side infinite value and right side 0 value. So in here marked pointer marked on right side of the dial. Suppose when the terminals AB are opened, so current through unknown resistance is 0. Here unknown resistance Rx equal to infinity. So in that case, pointer position marked on infinity. So that means point marked on left side of the dial. So this is the calibration position of series type of ohm meter. So by the using these movements, now we can measure our required multiplier resistances R1 and R2. By the using this procedure, you can calculate value of R1, R2, and you can calculate off scale deflection movements also. So that means now you have to calculate middle value of the unknown resistances. So second one, shunt type ohm meter. So with the help of shunt type ohm meter, you can measure unknown resistances. Is also having one battery, one switch, and one resistance and unknown resistance. So here our target is we have to find the our required shunt resistance value and unknown resistance. So now you have to calculate calibration of the shunt type of series, shunt type of ohmmeter. So initially terminals AB are shorted. So unknown resistance Rx equal to 0. Now current flows to the meter is 0. So in this case pointer marked on left side of the dial. So when terminals are open, unknown resistance Rx equal to infinity, I is maximum. So in that case you can observe position of the pointer marked on the right side of the dial. So this is the procedure to understanding calibration of shunt type of ohmmeter. So now I will explain applications of ohmmeter. So here you can observe 4 applications. First one, this meter is used to measure the resistance as well as the connection of the components in an electrical circuit. So it measures the resistance in ohms. So the micro ohmmeter is used to calculate low resistance. Mega ohmmeter is used to calculate the high resistances. Additionally, with the help of ohmmeter, you can check continuity of the circuit. So these are the applications of ohmmeter. So now I am going to explain multimeter. Your multimeter is basically a PMMC meter. So with the help of multimeter, you can measure voltage, current, resistance, so like that. So with the help of multimeter, measure DC current, the meter acts as an ammeter with low series resistance. Here multimeter consists of ammeter, voltmeter and ohmmeter. So combined with a function switch to connect the directional moment. So actually with the help of multimeter you can measure micro values and milli values also. So you can call as micro ammeter and on milli ammeter. This is the circuit diagram for the multimeter. So this having nearly 4 sections. So this side you can observe DC voltage and this side you can observe AC voltage. So that means this meter you can use for DC voltages as well as AC voltages. So that means this will act as a DC voltmeter, DC ammeter, AC voltmeter. So with the help of the circuit diagram, you can calculate voltage, current and resistance in ohms. So actually that multimeter having sections are like this. So actually this is the circuit diagram of the multimeter. So in this circuit diagram now you have to separate DC voltmeter. So DC voltmeter you can observe so like this. This is the DC voltage section. So now you have to consider, so from here to meter, so join like this. So you can observe like this. So some part of the DC voltages and some part of the main circuit diagram. So with the help of DC voltmeter, you can measure values from 0 to 1000 volts. So here a DC 1000 volts, which is an external voltage jack. The external jack is used for the measurement of DC voltage up to 1000 volts. So this is the function of the DC voltmeter. Next, AC voltmeter. So this is the right side section and some part of the diode section. Here I have taken two diodes, D1, D2, one diode for rectification, other for protection of the meter. So this is the AC voltmeter. So observe here. So this is having AC voltage section and 1 meter, 2 diodes and combination of some resistances. The AC voltmeter section so shown like this. In case of AC voltage measurement, the half wave rectified the output voltage of a device and then passing through the meter. The purpose of the other diode connected across the meter for protection. So see here, this is the meter. So across meter we have connected one diode and one for using rectification purpose. So this is the idea about AC voltmeter circuit diagram. Next section, DC ammeter. So actually here multimeter circuit having ammeter section like this. So actually ammeter having combination of the one deflection moment and resistances. So actually here this meter used for the measurement of DC milliamperes and microamperes. Ohmmeter. So this is the ohmmeter section. The ohmmeter section of a multimeter as shown like this. So these are the equivalent circuit of the ohmmeter section. So this having one PMMC meter and combination of the some resistances. Now you have to simplify the resistances. So like this. So here this is the first section. Now consider equivalent of the first section. So you will get like this. Again simplify them. So here you will get 10K value. This is the 1 mega ohm. So now we have to connect 120 ohms across. So these two resistances. So simplify them, then you will get 100 ohms. So this is the off scale deflection resistance. So you can simplify like this also. So I have written here in the 10K range, the 102 ohms resistance is connected in parallel with the total circuit resistance, and in the 1 mega ohm range, the 102 ohm resistance is totally disconnected from the circuit. Therefore, on the 1 mega ohm range, the half scale deflection is 0 kilo ohms. Since on the 10 kilo ohm range, the 102 ohms resistance is connected across the total resistance. Therefore, in this range, the half scale deflection is 100 ohms. So you can observe like this. This is the resistances part. So simplify them, then you will get like this. Again simplify them, so you will get 1 mega ohm section like this. So now you have to connect 102 ohms across these two resistances. Then you will get 100 ohms. So this is the half scale deflection. So this range is the half scale deflection range. At this stage you will get our required resistance is 100 ohms. So this is the function of the ohm meter circuit. Now I will show short video on multimeter.
Multimeter. Multimeter is an electronic instrument which
So
is
this
used
is
to
the
measure voltage,
multimeter.
current,
With the help of multimeter,
and
you can measure
resistance.
voltage, current, and resistance.
This is called as
So
AVO
meter,
meter, that is
ampere
ampere
voltage
ohm meter.
That is we can call
The
AO
internal circuit
meter.
of the multimeter is
This is
shown
the
in the
circuit
animation.
diagram for multimeter.
It consists of a moving coil galvanometer. By incorporating suitable circuits with the galvanometer, the measurement of voltage,
So with
current,
the help of multimeter,
and
you can measure
resistance can be
voltage,
done.
current, and resistance.
Let us consider a galvanometer of resistance G, that is equal to 100
So
ohms,
here
which gives a
galvanometer
full-scale deflection for
having
1
100 ohms.
milliamperes.
That means here every meter having some
How
internal
can
resistance.
a multimeter be converted
Rm
into an
is equal to 100
voltmeter?
ohms. Multimeter converted into a
The moving
voltmeter.
coil galvanometer is
So this is
converted
the
into a
galvanometer.
voltmeter by connecting
So
in a
that
series
having
a
two
high
terminals are
resistance
like
of
this. One
suitable
is
value.
positive and other one is the negative.
If a high
So
resistance
here
of 900
this is the
ohms is
resistance.
connected in
We are
series with the
taking a 900
galvanometer,
ohms
the
high
range of the
resistance.
voltmeter becomes 10 raised to minus 3 into 1000,
So
that
that
is equal
means
to 1
10 to the
volt.
power of minus 3 into
The
1000
same
equal to
meter
1
can be
volt.
used to measure voltage up to 10 volts if a resistance
So this will
9900
pass
ohms
10 volts
is connected in series.
voltage.
Thus, in order to
Resistance
measure
is
different ranges,
9900.
different high resistance are put in series with the
9900 ohms.
galvanometer by a switching
So this
arrangement.
is the meter.
How can
So
a multimeter be converted into an ammeter? The galvanometer is
So now
converted
take
into
one
an ammeter
galvanometer. So that having
by shunting it with suitable low resistance, one for
connections
each
are like
range.
this. Now you have to connect
For example, the galvanometer
across
can be
shunt.
converted into an ammeter with the range 0 to 1 ampere
So
by
the
shunting
galvanometer
it
can
with
be
the resistance
converted to
of
ammeter with
100
range
by
0 to 1 amp
999 ohms or
by shunting with the
0.1
resistance of
ohm
100 to
approximately,
900 or
and the range can
0.1
be increased
approximately, and
by
the range can
10
be increased
amperes
10
by
amp shunting it to
100
100
by
by
9999 ohms,
9099
that is
ohms.
0.01
Simplify them,
ohms
then you will get
approximately,
0.01 ohms
and so on.
approximately, and so on.
How can a multimeter be
So multimeter
converted into
converted
an
into
ohm
an ohm
meter?
meter.
The galvanometer is converted
So
into
now
an ohm meter
consider one
by
galvanometer.
connecting a battery
So
and a
connected one
suitable
battery
resistance in series.
resistance in the
If
series
a
form.
battery of 1 volt is connected in series
So this in this
and the
stage,
above
this
galvanometer
will give
shows
voltage
full scale deflection,
1 volt battery.
then the total resistance in the
Consider 1 volt
circuit,
battery.
including
Then the
that of
total
the
resistance
galvanometer, be
in the
1000 ohms.
circuit be 1000 ohms. So this is the conversion of the ohm meter.
Multimeter. Multimeter is an electronic instrument which is
So next, some important terms. Significant figures and conformity are the important terms. So now I will explain significant figures. Significant figure gives a actual information related to the magnitude and the measurement precision of the quantity. So actually here precision means clearly defined. So that is called the precision. Clearly defined and sharply, that is called the precision. So here also you have to show like this. So the number of significant figures in which reading is expressed gives the extent of precision value. Suppose one instrument specifies a resistance of 230 ohms. So now here 230 is closer to 229 and 231. So that means this is having three significant figures. So it is specified 230 ohms as, then it is clear to 230.1 ohm or 229.9 ohm. So in this case, the total number of significant figures are 4. So you can observe like this. Start from 229 ohms. Next value 229.9 is closer to 230. After that you can write 230.1. So here we are having 4 numbers. So we can write the total number of significant figures are 4. So this is the idea about significant figures. Next, conformity. Conformity is one of the characteristics of the precision. So suppose I have taken one resistor value. So resistor value 7395651 ohms. So taken like this. So now this you can write 7.4 megaohms. Is also approximately value. So but not correct. The true value of the resistor and this error is created due to the scale reading. So limitation and is precision error. So actually here 7.4 megaohms is nearest to value of 7395651. So this is called the conformity. These two are the important terms. So now I will explain some important problems. Problem 1, two resistor R1 and R2 are connected in series with R1 equal to 87.5 to 28.7 ohms and R2 equal to 3.62 ohms. So calculate the total resistance to the appropriate number of significant figures. So now you have to calculate significant figures. So now write solution. Given R1 is equal to 28.7 ohms. So now this is the 3 significant figure. Next, given R2 equal to 3.62 ohms. So this having four significant figures. Here we have taken R2 is 3.624 ohms. So I have written R2 equal to 3.624 ohms. This having 3 numbers, that is the reason this is the 4 significant figures. So now find total resistance. That means now you have to add value of R1 and R2. So find here total resistance RT equal to R1 plus R2. So now simplify them, then you will get R1 equal to 32.324. So now this having 5 significant figures. So you can write this value as 32.3. So that means 3 significant figures. This is done because one of the resistance accurate only to 3 significant figures, and therefore the result should also be reduced to their significant figures, and hence the value of R1 equal to 32.3 ohms. That means here, so you have to show something in the precision, because of your precision is the clearly and sharply defined. So that means now you have to show our value clearly and sharply. That's why we are taking our total resistance instead of 32.324 as 32.3 ohms. So now this is having 3 significant figures. So this is the idea about significant figures. So next I will explain one more problem. So 2 voltmeters with range of 0 to 100 volts has the sensitivity of 10 kilo ohms per volt and 20 kilo ohms per volt. When these 2 voltmeters are connected in series, then find the maximum voltage that can be measured. So here finally you have to calculate value of the resistance R1 and R2 by the using sensitivity values. So already given first sensitivity, first meter sensitivity 10 kilo ohm per volt. So here both are connected in the series form. So that means you can draw our required circuit diagram, combination of 2 meters connected in series. So like this. So now we are providing some voltage to meters. So V maximum. So this is the voltage. First meter. So given sensitivity 10 kilo ohm per volt. For second meter, given sensitivity 20 kilo ohm per volt. So now you have to calculate one by one. First, I am going to calculate value of the first resistance value of the first meter. So already given S1 value is equal to 10 kilo ohms. So already you know the sensitivity of the meter IFSD. Sensitivity of the meter S1 is equal to 1 by IFSD. Now write IFSD equal to 1 by S1. You know the value of S1, substitute here. So then you will get 0.1 milliamps. Now calculate resistance R1. Here resistance R1 equal to voltmeter sensitivity and voltmeter range. So already given voltmeter sensitivity as 10 kilo ohm per volt, substitute here. So given range 0 to 100, this is the maximum range, maximum voltage. Now so right here 100 volts. So So simplify them, then you will get 1000 kilo ohms. You can write as 1 mega ohm. This is the first value. So come to the next one, given sensitivity equal to 20 kilo ohm per volt. So now calculate value of IFSD by using sensitivity. Here you can write IFSD equal to 1 divided by S2, where IFSD is the full scale deflection current. So now calculate here. So already given ST equal 20 kilo ohm per volts. Substitute here and simplify them, then you will get our required IFSD 0.05 milliamps. Now calculate value of R2. Here R2 equal to voltmeter sensitivity and voltmeter range. Here voltmeter sensitivity 20 kilo ohm per volt and 1000 volts. So simplify them, then you will get 2 mega ohms. So this is the second resistance of the meter. First one having resistance R1 and second one R2 according to our problem. So now find the maximum voltage and can be measured. So now add total resistance in the circuit. Here R equal to R1 plus R2, add them, then you will get 3 mega ohm. So already you know the value of I 0.05 milliamps. Actually in this slide we got first current 0.1 milliamps and the second current 0.05 milliamps. Now here, so you have to consider minimum current value. Here 0.05 milliamps is the minimum current value. So take that as the I. So consider the minimum current when the voltmeters are connected in series. So here voltmeter 1 reading is equal to IR1. Now here you have to calculate individual voltage in the meter. So voltmeter 1 reading equal to I into R1. So already you know the value of I is 0.05 milliamps and R1 equal to 1 mega ohm. Simplify them, then you will get 50 volts. So now second voltmeter reading equal to I into R2 is equal to 0. So now come to here, this equal to 0.05 milliamps into 2 mega ohm. So simplify them, then you will get 100 volts. So these are the two voltage per meter 1 and meter 2. So next I will explain one more problem. So an MC instrument has uniform scale with 100 division. Its full scale division is 200 volts. If 1/10 of the scale can be estimated with 2 degree of accuracy, then find the resolution. So here you have to find the resolution for the given values. So here given full scale division 200 volts. So instrument has uniform scale with 100 divisions. Now calculate resolution. Resolution equal to 200 divided by 100 equal to 2. If 1 by 10th of scale estimate 2-degree accuracy, then you will get a resolution equal to 1 by 10 into 2. So now you can observe resolution 0.2 volts. This is the problem on resolution. So up to here I have completed unit 1. So in the next video I will start unit 2. So once again, before going to start unit 2, once again I will recall the unit 1. So actually in unit 1, first topic has block diagram of the measuring system. So actually here that block diagram contain blocks as measuring, some transducer and conditional amplifier, finally output display. So now with the help of transducer you can find measuring value, that is called the quantity. So you can call quantity as measuring. So whatever the element, that element you can call as measuring. Examples: resistance, capacitance, temperature, humidity, moisture, so like that. So whatever the quantity, that you can say measuring. So transducer that converts any non-electrical variable into electrical variable. That is the function of the transducer. So generally here we are having 5 classification of transducers. According to that you can utilize transducer. So actually your output of the transducer weak signal with the help of conditional amplifier. So you can improve the output of the transducer signal. So finally you have to see output in the display. That may be CRO or X-ray recorder, so like that. The same you can use some other display systems also. So this is the measuring system. So to understand measuring system, you have to study characteristics of the measuring system. So you can say that are the performance characteristics of the measuring system. So actually your measuring performance characteristics of the measuring system, you can classify it as 2: static characteristics and dynamic characteristics. Static means memoryless, dynamic means memory. So to understand memory type of characteristics, we need help of some input signal. Here I have taken input signal in the form of unit step, unit ramp, parabolic and impulse signals. So with the help of these signals you can study speed of response, fidelity, lag, repeatability, reproducibility. So these are the dynamic characteristics of the measuring system. So actually here every system, so we'll give some errors. Generally here you can identify 3 types of errors. One is the random error, one is the gross error. Gross errors are the human mistakes, and other one is the systematic errors. So systematic errors you can identify in 2 ways: instrumental errors and environmental errors. So next one, random errors. The random errors occurs due to the reason of noise. So with the help of some mathematical expressions we can avoid such type of errors, or you can calculate such type of errors. So to understand random errors, now I have taken help of the statistical approaches. So here I have taken 5 statistical approaches. First one is arithmetic mean, and second one is standard deviation from the mean. third one average deviation, and fourth one standard deviation, and fifth one variation. So by the using 5 mathematical approaches, we can understand random errors. So next one, measuring systems. So to study measuring systems, we have to take help of the galvanometer. So your galvanometer is some mechanical device. So actually here in this case we are taking galvanometer in the form of analog device. Instead of that, you can also digital also. So actually here analog device having some PMMC movement. So you can call as galvanometer also. In the same you can call basic meter also. So with the help of this meter, so you can calculate voltage, current, so like that, resistance also, so like that. So here we are having 3 types of measuring devices. First one is the DC voltmeter. So actually a DC voltmeter having one multiplier resistance, one PMMC movement. So with the help of multiplier resistance, you can protect the meter. So by the using DC voltmeter, you can measure multiplier resistance and voltage. So generally here you can calculate multiple types of multiplier resistances and different voltage levels also. That is the reason we have to extend our single DC voltmeter as a multi-range DC voltmeter. That means this having number of multiplier resistances and number of voltage levels. So next one, practical multi-range DC voltmeter. So with the help of multi-range DC voltmeter, you can measure different multiplier resistances and different voltage levels with the help of switch. So in the same way, you can extend this meter some area. That means you can call as extension voltage range. So here additionally you have to take RSH in the circuit diagram. So where RSH is the shunt resistance. So here our target, you have to find our extension range RSH is equal to Rm into M minus 1. So where RSH is the shunt resistance, Rm is the internal resistance of the meter, and M is the number of times. So you can by the using this equation you can calculate RSH. So next one, DC ammeter. So with the help of ammeter you can measure current. So generally here we have again 3 extension parts of the DC ammeter. First one, multi-range DC ammeter. That means here, so with the help of this circuit you can calculate number of shunt resistances and number of voltage, number of current levels. So actually here ammeter having 1 meter, 1 shunt resistance and 1 power supply and 1 switch also. So with the help of switch you can change position of the current levels. That means you can at every time you can measure different shunt resistances. So this is the multi-range DC ammeter. So next one, Yarton shunt multi-range ammeter. So it is also similar to multi-range ammeter. So with the help of MBBT switch, so you can every time you can change position of the current levels, and every time you can calculate shunt resistance values. So another name of the Yarton shunt multi-range ammeter is called universal shunt. So actually here with the help of universal shunt, we can measure shunt resistances, currents without help of the meter. This is the advantage of the universal shunt ammeter. So with the help of these meters, so you can measure n times of shunt resistance and n times of current levels. So next one, ohm meter. So with the help of ohm meter, you can measure resistance in ohms. So with the help of ohm meter, you can check continuity of the circuit diagrams also. Circuits also. So here we can observe two types of ohm meters. First one is the series type ohm meter, and the second one shunt type ohm meter. So here the series type ohm meter having two resistances, one PMMC meter. One resistance will act as a multiplier resistance, other one is resistible resistance. So across the terminals AB you can connect unknown resistance. So where unknown resistance is our required intermediate resistance. That means here with the help of ohm meter, you can measure unknown resistances at different conditions. So towards that we have to take help of the calibration of the series type of ohm meter. By using the calibration of the series type of ohm meter, so you can measure values of R1, R2 and RH. So next one, shunt type ohm meter. So with the help of shunt type ohm meter, you can measure resistance in ohms. So actually here also you have to take help of the calibration of the shunt type resistance. So that means here also you have to calculate unknown resistance. Actually this circuit having one PMMC meter, one battery and one resistance and unknown resistance across terminals at a different by using different conditions. So you can calculate value of the resistances and unknown resistances. Here unknown means that is the intermediate values. So this is the idea about ohm meter. So finally, so we study multimeters. So multimeters is the combination of the voltmeter, ammeter and ohm meter. So combination of these three circuits is together multimeter. So once again I will tell you, first one voltmeter, second ammeter, third one ohm meter, together is called the multimeter. So with the help of multimeter you can measure voltage, current, resistance. So current in different manners, ohms, voltage in different manners, and resistance is also in different manner. So this is the function of the multimeter. So now I have finished unit 1. So in the next video I will explain unit 2. Okay, thank you.